to provide you with the most theory exercises, so I hope yes. Have a good day. Okay. Bye. So that's the period of our observations, containing 80% of our observations. So let's go to question F. We have to determine if x3 is below 2 and x5 is above 3. What does it mean? We have already the table of the relative frequencies. So we just can calculate it, meaning that if x3 is less than 2, it means that we have that period here. Because it's less than 2, we don't have an equal sign, so we don't include 2. And for x5 more than 3, it's above 3, so it means above or equal. So it means it's 3 and 4. And it says and, not or, and that's why we multiply those two numbers. If we have to continue to point G, we have a new event, Y, the number of households that have at most one subscription. So we have to determine the probability of having at most 9 such households. So it was set, or it would have been plus. Yes, exactly. If we have and, it means that the first and the second event are happening at the same time. If it means or, it means that you can have either the one event or the second event or just the two, both of them. So the number of our households that we are interested in the probability of having 9 at least households that have at most one subscription. What we should do in that situation? We basically have to find all numbers, all probabilities that are either equal to 9 or equal to 10, because we have just 10 households. That's the maximum. And from 10 households, the first variant is having just 9 households with one subscription. It means that from those two we have to select just 9, and having the probability of success, which is 0.83, to the power of successes, which is just 9, and to multiply it to the probability of having a failure, which is 0.17 to the power of 1, because we have one failure, 10 minus 9. But we have another event here, because it says equal or more. It means we have either 9 or either 10. So the second option would be to select from those 10 events, from those 10 households, just 10. So it's 10 times over 10 times the probability of having the success, which is 0.83 to the power of 10, because we have 10 successes. And if you have to multiply by the probability of having a failure, but to the power of 0, because we have 10 out of 10, this should be just 1. So it doesn't matter. And in the end, the probability should be equal to 0.47. Do you have a question about that exercise? If not, I would say, let me see. We have one last exercise. That's the very, very last, I think. Yes. So we have a manager of a company that has a random variable X, and it's interested in the number of employees that are absent per day. And here we are given the table of distribution. Firstly, we have to describe how the graph of the corresponding cumulative distribution function would look like. So we just have to find the cumulative distribution of the graph, because we here have the PDF. So for each separate x, we have a separate number, but we have to find the cumulative. That it means, I'm going to just add a row here. For 0, we would have 0.10. But for 1, we would have 0.20 because we just sum up those two numbers here. Then we would add up 0.40, it becomes 0.60. Then it would become 0.80. And now gradually we are moving towards 1. In the end, should be equal to 1, hopefully. Then we would get, adding 0.15, you'd have 0.95. Plus 0.05, fortunately, is just 1. So we are correct. So if you have to sketch that up, here we have x, here we have f of x. And now we are just, let's make it longer. We're just looking at those numbers that are above. At 0, at 1, and up until 5. So firstly, you have 0.10, which let's imagine is somewhere here. Nextly, we would have 0.20, which is from somewhere here. You just try to draw those numbers that are above, that are below the table,